Hey, David here from Agile Tech Support. Today I'm talking about virtualization as a concept and how it's used as a tool for business expansion. When I say virtualization, I'm not talking about virtual reality and I'm not talking about any online virtual world. I'm talking about virtual machine technology, which is a major field of study in the computer science domain and which has produced game-changing technologies for business over the last decade. I'm specifically talking about system VMs, which provide the functionality to run entire operating systems, not process VMs like the Java runtime and Wine for Linux. Virtualization is all about emulation of a particular computer architecture in addition to distributed hosting of a virtual machine. So what is emulation? Well, simulation is about replicating the behavior of a system or device in a certain context. So a flight simulator is all about replicating the behavior of an aircraft from the perspective of the pilot. Fluid dynamics software replicates the behavior of gases and liquids in motion from an engineering perspective. Emulation is about more than just simulating behavior. Emulation aims to replicate the internal functions of a particular machine or system architecture, typically by imitating that system. One example would be a prosthetic shoulder joint. The prosthetic is not the real thing, but it works exactly the same as a human shoulder joint will. It does more than simulate the joint, it completely replaces the joint. An electric guitar is a perfect example of hardware emulation. It emulates the functions of an acoustic guitar by converting the vibrations of steel strings into electric signals, which are then fed into an amplifier. In effect, it completely replaces the acoustic guitar and can emulate several different types of acoustic guitars by modifying the output signal. When we talk about virtualization, we're mostly talking about hardware emulators, but software emulators do exist. Emulators started off as a way to run game software developed for old platforms like the Nintendo game console. This meant you could play the original Mario Brothers software on your PC, even though that software was only ever designed to run on a Nintendo. In ICT today, whole computer architectures are emulated in software, which allows flexible software packages to emulate a range of different hardware platforms. And this effectively allows any operating system software to run on any hardware platform as a virtual machine. Needless to say, some system vendors don't particularly like this idea because they put a lot of effort into building software that will only run on a particular hardware platform. And this is why big tech companies have put intellectual property restrictions in place, e.g. Apple's efforts to stop people running a copy of Mac OS on a PC. Distributed hosting is all about separating the offline state of software from its online state. The online state is the volatile software environment that a running operating system creates. The offline state is the stored data that persists between boot cycles. A computer in isolation must host both its own online state and its own offline state. Networked machines can store the offline state on a separate machine, and this is what distributed hosting is all about. The VM can be hosted by the client machine or a server machine. A client-hosted VM architecture will look like this. A physical server will host the VM server software. This server software will store multiple offline VMs. These are called guest operating systems. A separate VM might also run on the server to host the administration interface. Endpoint hardware connects to the server via a network. Emulation software, known as a hypervisor, runs on the client endpoints. This hypervisor hosts the online virtual machine instance. These hypervisors are capable of running multiple VM instances, but for most clients that's typically not the case. If these endpoints were servers, you might run multiple VM instances. In this client-hosted architecture, the server's main role is to store and manage VMs in their offline state, not to run VMs in their online state. A more common architecture is the server-hosted VM, which will look like this. So the endpoint runs no software, except for some very basic embedded firmware. So it acts as a simple terminal, just handling input and output of peripheral devices like mouse and keyboard. And in this setup, the endpoint is called a thin client with a bare minimum of hardware infrastructure and practically no software infrastructure. This makes for very low capital expenditure, low operational expenditure, and fast endpoint deployment. The VM server runs one or more hypervisors, which host the VMs in their online state. This means the OS relies entirely on the physical server infrastructure, which centralizes the majority of the capital expenditure, and it streamlines the system admin role, thereby reducing operational expenditure. It does place heavy requirements on the server, but server hardware and good quality server software is designed to run 24/7 with absolute minimal downtime. This type of deployment is referred to as Virtual Desktop Infrastructure, or VDI. Not to be confused with Remote Desktop, which is a completely different technology for controlling a desktop application across a network connection. Most VM server infrastructure now also includes a repository for offline VMs. This is particularly useful for storing multiple snapshots of the same VM, which effectively adds version control and disaster recovery to the system. This architecture places significant load on the network, so it should really only be used across a local area network or a dedicated high-speed, low latency wide area network. I don't recommend doing this across a public network such as the internet unless good quality of service standards are provided. So what are the features and benefits for business operations? The first new feature that virtualization provides would be a different approach to user provisioning. So provisioning is all about onboarding new staff, typically by giving them access to a computer network. Now, traditionally this meant providing a complete new workstation, a new OS and application software deployment, setting up new user accounts, maintaining that hardware and software infrastructure. With VDI, you simply provide a new thin client, or you can timeshare thin clients between staff, spin up a new VM instance, which can be done in a matter of minutes using a deployment script. The VM server takes care of the software licensing, user profile and version control. And there really is no need to maintain the endpoint because they come at such a low price these days that if something goes wrong, you just throw it in the bin and get a new one. They literally are a disposable asset these days and they're not worth maintaining. The ability to quickly and efficiently create VM snapshots improves the whole disaster recovery administration effort. A snapshot is effectively the same as creating an image of an entire offline OS and archiving it. Having all of this infrastructure localized to a single host machine makes the whole backup process more efficient. It also means you don't need separate backup software. Live migration is a feature that lets the VM manager migrate an online VM from one hypervisor to another without interrupting business operations. So if you happen to be running a cluster of VM server hosts, and the load on one machine becomes high enough that it's starting to affect performance. The VM manager can replicate a VM in real time on a host that isn't experiencing high loads. Then switch control over to the second hypervisor without any interruption to the end user, and simply terminate the old VM, which reduces the load on the first host. Another benefit of live migration is business continuity in the event of hardware failure on the first host. To use this feature, each VM has to be synchronized across both hosts in real time. That way, if one machine suddenly goes down, the other can take over with no interruption to business activities. Sandboxing is an inherent feature in all virtual machines. It means that you're executing applications in a software context that is isolated from the infrastructure that supports that software. In the ICT industry, it's known as a sandbox. This has definite security benefits across a local network because an operating system, its associated hardware and application software can be fully virtualized. Deploying a new VM purely as a test VM becomes very straightforward. Software patches from the developer can be applied to this separate dedicated test VM instance before they're applied to the rest of the VM instances. And this helps verify the security of those patches in a quarantined environment. If the patch is tainted, at worst, the test VM becomes corrupted. You simply terminate that VM instance and deploy a new instance within minutes. Sandboxing is also used in software development for similar reasons. Commercial software goes through several test phases. Alpha testing is carried out by the developers in a simulated environment. Beta testing is carried out by the customer on their own production equipment. This will usually be done in a sandbox because the customer doesn't want to risk damaging their vital infrastructure. It also allows the developer to independently profile the performance of the new software and study its runtime behavior. The other potential feature of virtualization is hardware abstraction. So providing separation between the primary purpose of an OS, which is to manage resources, and a secondary purpose, which is providing compatibility between the hardware layer and the application layer. Some of the big tech companies like Microsoft and Intel have used vendor lock-in as a sales strategy over the years. For example, if you wanted to run a Windows server, you had to use an Intel CPU. This was not by accident. Intel did a deal with Microsoft because they could see that Windows Server was about to dominate the ICT industry. Emulation means you can usually procure software on a completely separate basis to the way you procure hardware because they will always be compatible, so long as the virtualization layer provides that compatibility. This means you can go through several generations of hardware without needing to upgrade your software. Good quality software will always be good quality software, and you pay a significant fee for a perpetual license, so you want to get the most out of it. Software licensing usually works differently when deployed onto a hypervisor. In the past, if you had one physical machine, you could only run a single operating system at any time. Then the processing hardware evolved to include multiple execution cores per CPU, on top of the ability to run multiple CPUs per host. Then virtual machines came along as a mainstream product, and this meant that you could have dozens of online operating systems running in parallel on the same machine through virtualization. The software vendors weren't about to let customers do all of this for the price of a single license. So now they license software use based on how many physical instances and how many virtual instances you want to run. And because server OS software becomes more efficient as processing power goes up, they also restrict how many cores you can use per license. So the bottom line is virtualization gives you more flexibility in how and when you upgrade an OS. There are some disadvantages to virtualization. It often adds complexity to the whole system because certain tasks have to be interpreted by the hypervisor before they're given to the hardware layer. The general rule with software is to aim for simplicity as much as possible, but an operating system is anything but simple. Adding another layer between the OS and the hardware only makes runtime behavior less predictable. This can affect overall system stability. Some very specialized applications just don't work well in a virtual machine. So examples would be anything that needs direct access to the hardware layer, e.g. Video encoding, mission critical or time critical appliances, e.g. avionics software, high performance computing applications, e.g. stock exchange, high security systems, e.g. ATM software, and legacy software that relies on a redundant technology stack. So for example, if you're still running IBM's Warp OS that failed to take off commercially, don't expect that a modern hypervisor will necessarily support it as a guest VM. The other disadvantage is that virtualization can create a single point of failure for your entire ICT infrastructure. Where in a traditional architecture, the loss of a server might mean losing access to a database or losing network access, you could still perform completely local operations on your endpoint. And you could probably reconfigure the physical network to provide temporary internet access. For a small or medium business running a virtual desktop architecture with only one physical server, you run the risk of losing everything. This is why virtualization is really a tool for business expansion, not usually a replacement for existing ICT infrastructure. The first thing that SMB owners should look to virtualize is any redundant on-premise server infrastructure. So I see small business with maybe a dozen endpoints running a Windows server on a dedicated host just for network control and email hosting. This is just not an efficient way to provide those basic services for a dozen endpoints. Yes, it provides more privacy than using the cloud, but most of the time these servers are not being administered properly, so you end up with poor security anyway. In this case, a modern commercial grade router with a self-managed network OS is a better option for most SMBs. You're looking at half the capital expenditure and very low operational expenditure compared to a Windows server. You would use public cloud VMs to host an email server and have it replicated across multiple data centers to add redundancy. And these capital expenditure savings can then be converted into more endpoints. I also see a lot of small businesses using legacy software that still works perfectly okay, but it's no longer supported by the developer, and therefore it's not compatible with modern operating systems. Usually this is accounting or some other ERP software that has been superseded. Maybe the software is only licensed for a single endpoint, so replacing the hardware is not really an easy option either. Rather than just hoping your old laptops don't die, why not virtualize the entire machine onto a server and just start that VM when you need that specific application? Let's say you have a single office that relies on workstations and a physical server, and you're expanding to multiple office locations. Rather than set up new physical servers at each of the new locations, you might consider a virtual desktop infrastructure. This would allow you to still run a single server and would minimize your deployment expenses at the new locations. You would require a virtual private network with a well-defined quality of service, but it's probably still a better long-term option. Okay, so let's take a look at some specific products. The Type 1 hypervisors, also called bare metal hypervisors, will run directly on top of hardware. You can run multiple OS instances as virtual machines. with the application software and the middleware on top. The market leader here is definitely VMware with their vSphere product. Microsoft have made good ground by bundling their Hyper-V product with the Windows Server editions, and Citrix have managed to develop the Zen architecture, which was originally an open source project, into another very capable product. Oracle have also a pretty good presence. Type 2 hypervisor is hosted by an existing operating system, which adds another layer to the stack. So this is the sort of architecture that you end up with. It's also called a hosted hypervisor. The market leaders here are again VMware with their workstation product, Oracle's VirtualBox, which is open source freeware, Parallels Desktop. These guys specialize in Windows emulation on a Mac OS system, and KVM for Linux users. Unless you're deploying a test environment or have a small operation, you're really going to want to use Type 1 hypervisors. Type 2 just adds complexity to the infrastructure. So in conclusion, virtualization is all about emulation of a hardware platform and an operating system, which results in a virtual machine, implemented purely in software, but effectively replacing an entire machine. Industrial grade virtualization is about handling a virtual machine in its offline state as well as its online state, and managing snapshot images of that VM. These VMs may run on the client machine, but more likely they'll run on a server or within a server pool for efficiency. Virtualization is a tool for business expansion. It's not a replacement for existing infrastructure. It was designed to improve return on investment for IT procurement and to provide an abstraction between the hardware layer and the application layer. And that's about all I've got for today. Tune in next time.